Hi guys, I'm making a new video about ferromagnetic materials because there's something I want to clarify that I said in the previous video. You can see over here these coins do stick to the magnet. Look at that. And you'll find that Taiwanese coins don't stick to the magnet. Now these coins are copper plated, it's true. But it's not the copper that's making them stick to the magnet. As you can see over here, I was looking at this. Look, this is pure copper. Copper is not ferromagnetic. Look at this copper. This copper is not sticking to the magnet at all. So copper does not stick to magnets. Copper is a very good conductor of electricity. Not many things are better than copper for conducting electricity. Gold and silver are better, but very expensive. Graphene, remember we did the graphene thing. That's better than copper at conducting electricity. But it's a very good conductor of electricity, but it's not a ferromagnetic material. So why do these stick to the magnets then? And the reason is because they have steel. Look, I'll give you three of them. They have steel. They have steel inside. So it's the steel, and steel is mainly iron. Remember, steel, which contains iron, cobalt, nickel, these things are ferromagnetic. Many things are paramagnetic. So this aluminum over here, as the Americans say, aluminium, as is the correct way to say it, this does not stick to the magnet. But if I were to get a super duper strong magnet, like the other video that I have for you in the electronic communication book, if you were to get a super duper strong magnet, you could get some attraction. You could get the aluminium to stick a little bit because it's paramagnetic. It's weakly, it can be weakly attracted to a magnet. Very, very weak. But it's so weak that no attraction to this magnet that I can notice. Now this can, over here, it sticks. You can't tell, but look, when I get close, it just sticks. It just sticks. I'm not pushing it, it just sticks. And this is a tin can. So the outside of this can is tin. But tin actually does not stick to magnets either. Tin is not ferromagnetic. So why does this can stick to the magnet? And that's because inside, it's the same thing. Inside here there's steel or iron. So it's the iron inside the can, not the tin on the outside. So tin cans stick to magnets, and certain copper coins stick to magnets not because of the copper and not because of the tin, but because of the iron inside. So all you really have to do, right over here we have a galvanized nail. So this nail has zinc on the outside. Ooh. But it's not the zinc, it's the steel that's inside that's sticking to the magnets because of all the steel. And we have a magnesium thing over here, and it's, not really sticking very strongly to the magnet. So all you have to do, don't worry, you don't have to know what the material is. This is an aluminium chopstick. Chopstick is not sticking. You don't have to know what the material is, but what you have to do is you have to go around the house and find 3 metals, it was yesterday's homework, that stick to the magnet, and 3 metals that do not stick to the magnet. Make sure they are metals. Don't give me plastic. Of course, the plastic is not going to stick. Okay, give me metals. And you don't have to say what the metals are. Just say chopstick, coin, can. Okay, you can just say the name of the object. You don't need to know the kind of metal that it is. But yeah, I just wanted to make that clear that copper is not ferromagnetic. So only a few materials are ferromagnetic. It's not that many. All right. Thank you guys. I will speak to you guys later in the class.